Thank you so much for watching this online video tutorial. Like, comment, and share, as well as subscribe to our channel at Good Better Best Online Videos for more video content. Okay. Hello, welcome everybody to grade 9s. Welcome to our session for term 4. Okay, whoever's watching this video, welcome back. We're going to have a look at the topic Earth as a system. Okay, two main little bubbles there we're going to focus on is spheres of the Earth and systems. Okay, breaking the main topic up into two subtopics. We're going to further break up this one, which is spheres of the Earth. I'm going to list them here quickly. All right, we got the first one, which I believe is the lithosphere. Or actually it's yeah, it is the lithosphere. I'm correct. Yeah, the lithosphere. Been a while since I did this. Then we're going to have a look at the hydrosphere. Okay, hydro should indicate to you what that sphere is all about. And then we're going to have a look at the atmosphere. All right, which we use a lot. And then we're going to have a look, of course, at the biosphere. Okay, so most of you might have only heard of this one. The most common one, of course, the atmosphere. All right, and people also use this interchangeably. All right, that the atmosphere is also something that is, you know, actually all around us, the atmosphere. Kind of not correct, okay? But we'll obviously break this up into what each sphere is and where it belongs on Earth. All right, where it belongs. Okay, so I believe in grade 7, I think as far back as grade 7, you learned that natural scientists, okay, they do think of the Earth as having 3 outer layers, all right, called the lithosphere, and the hydrosphere, and the atmosphere. But there's another layer called the biosphere that actually exists in all 3. All right, biosphere is somewhere in all 3 layers. Okay, 3 main layers though. So if you just know about the 3 main layers, then you're good. Okay, I believe in grade 7 we might have also uncovered that there are different kinds of systems. Okay, that a system is when several different parts work together, all right, like a machine or something, and they interact with each other and they produce something that functions as one. All right, many different parts, many different systems within make up one big system that produces something with one purpose, or something as it's best described, that functions as one whole system. All right, but if one system obviously fails, then it's almost like the whole thing doesn't function at all. All right, a good way to think about a system like this, as it's described in Earth, is a car. All right, of course we've got mechanical working with electrical and everything like that, but soon as the battery is flat, the car won't start, even if the starter is working or the motor is fine. You know, so everything has to work with each other so it can function as one, which is a nice drive in a nice car. Yeah. All right, cool. So that's obviously what we're going to go through and aim to get through in the purpose of this tutorial. Okay. Okay, I'll save that for a little bit. I'll save that for a little bit later. But if you think about planet Earth, okay, and there's lots of documentaries on planet Earth. Blue Planet is BBC's famous series on Earth, Blue Planet. And I think they also have a planet or a Planet Earth series as well, or something like that. I can't remember. I was a big fan of BBC Earth, and used to when I used to watch it. Don't get much time to watch it anymore. Okay, but planet Earth is a system, obviously, with those various layers, like a car, that interact with each other to produce the features that currently exist. Okay, so let's look at each of the spheres. I'm going to do the lithosphere first. Okay, this is the more inner sphere. Okay, now with the lithosphere, okay, it's basically the layer of rocks. Okay, are you all familiar with rocks? Okay, you go to the beach, you see lots of rocks and stuff, for boulders. All right, it's layer of solid rocks and soil. Okay, near and on the Earth's surface. Okay, let's just get that sentence. Alright, Earth is with a capital E. Alright. And we will learn more about the lithosphere in the next unit. Okay, we actually have a separate unit just dedicated to just the lithosphere. Okay, so we'll learn more about that when we get there. Okay, we're going to break that one up. And also when you get to geography, you will also learn more about the lithosphere as well. Okay, then we've got the hydrosphere. Okay, now the hydrosphere, all right, this is water on the surface of the Earth. Okay, that's why I said hydro for water on the surface of the Earth. So this is rivers, oceans, etc., etc. All right. So it's all the water, seawater, fresh water, ice, or snow. Seawater, fresh water, so like I want to say unsalted. I'm not sure if that is the right term, but I was going to say salinated, desalinated or unsalinated. I don't know which term is the right term, but basically the opposite of salt water would be fresh water. The frozen water, which is ice, and including snow, which is basically like frozen rain almost. Almost. That's how I like to think about it. Okay, almost done. Got now the atmosphere, which I'm going to use orange for. Okay, the word that is used so often, you know, especially to describe the ambience. All right, the atmosphere is changing now and stuff like that. Now, the atmosphere, okay, in natural science, geography terms, whatever, or in academic purposes, the actual real word for, or the real definition of it, is basically the thin layer of gases. Okay, it's a thin layer of gases that is found all around the Earth. Alright, and in a picture, in a graphical representation, I'll show you, of course, where we would find the atmosphere. Okay. Thought something went horribly wrong there with the blackboard, sorry. And we're also going to learn more about the atmosphere in later units. Just we got the lithosphere we're gonna focus on, have a look on something else, and then we'll have a look at the atmosphere as well. Cool. So that's the atmosphere. I'm just going to pause here for a second. Alright, we're going to talk about something new, the biosphere. First of all, we were told at the beginning in the introduction, alright, this is found in all spheres. Okay, so it's found in the lithosphere, it's found in the atmosphere, it's found in the hydrosphere. Alright, it's basically is all parts of Earth where life exists. Okay, all living organisms and their interactions. Alright, so let's just get that down. All living organisms. There we go. And their interaction. Alright, with rocks, soil, air, and water. All of this equals the biosphere. Okay. Now you can find living things in the lithosphere. All right. For example, the soils. For example, in the soil and the rocks that cover the land. All right. Therefore, the biosphere is also part of the lithosphere. You can find living things such as fish in the hydrosphere, both in fresh water and in the seawater. Therefore, the biosphere also exists and is a part of the hydrosphere. Okay, you can also find living things such as birds in the atmosphere, all right, and other things that fly, all right, insects and all that kind of stuff as well. Flying insects, some flying. No, that's wrong. I think you get a type of bats. There we go. That's what they're looking for. Bats or other type of animal that can fly. All right. And therefore the biosphere is also part of the atmosphere. So if we need to draw a little graphical representation, okay, fortunately there's no way to insert a shape here, so I have to draw this manually. So let's just try and get it correct. Okay, so here we got the lithosphere with the L. Okay, there we go. Got the hydrosphere is your H. And then we got, of course, the atmosphere, right? A. Okay, but in all of them, all right, we have the biosphere. Okay, basically showing that the biosphere is contained as it overlaps into all of the atmospheres, or all of the spheres rather. All right, so it's found absolutely everywhere because there's living organisms in each of the spheres. Okay, and living organisms can exist in each of the spheres, so therefore the biosphere therefore can exist and does exist in all of them. Introducing the lithosphere. All right, now we're going to break the lithosphere up into two subtopics as well, called Earth structure as well as rock cycle. Okay, so Earth structure, we're going to have a look at history of the Earth, layers of the lithosphere, as well as composition of the crusts. Okay, and or of the crust of the Earth. Okay, so it's going to be quite a few drawings maybe that we're going to have to go through. Okay, and then we're going to go through the rock cycle. We're going to have a look at, of course, the different types of rocks that exist, which you will learn if you decide to take geography as well. Okay, we're going to have a look at the steps in the cycle, and we're also going to have a look at continuous. Okay, cheers, Caitlin. Okay, so that's what we're going to break it up into. So let's just go maybe have a look at the history of the Earth quickly. Okay, we'll just talk about it. Scientists think the Earth formed about 5,000 million years ago from a cloud of dust and gas surrounding the sun. Okay, that's a theory. They haven't proven it yet. The particles of dust clung together to form a huge ball of hot rock. It's now cooled on the outside, but it's still very hot on the inside, rather like a baked potato on your plate. All right, so that part is true. The state of the Earth is extremely warm. It's extremely hot. Okay, so that's why it's not ideal to dig through there. Okay, and we know that the surface of the Earth is obviously very hot because that's what volcanoes basically tell us. When a volcano erupts, it obviously releases magma, which is molten lava, which is basically like liquid fire. Okay, where does that come from? It comes from the surface. Comes from the center of the Earth, of course. Now, we do have a good idea of what it is like inside the Earth. Okay. Besides volcanoes, we have also invented some machinery that can drill holes to get some samples. All right. So for places that are too deep to drill, we send through sound waves. All right, and they have been measured as they travel through it. Okay, so the sound waves kind of gives us an indication of exactly what's going on in the center of the Earth. To be honest, I'm pretty much fine with the surface. I wouldn't want to know what's going on in the center of the Earth, to be honest. Hectic. Although, must be, I don't know. I guess I'd like to know how it looks. You know, anyway. There's a movie that depicted what it could look like, but that was a fantasy movie. I can't remember the name of it now. But anyway. Okay. Now, the lithosphere, if you break it up further, all right, the Earth has layers on the inside of it. Okay. There are 4 concentric layers. All right. Concentric, this means that there are circles that share the same center. Right. The larger ones will obviously complete the smaller ones or be around the smaller ones. All right, but we do know we've got a center of the Earth which is solid, which is called the inner core, and that's made of iron and nickel, whilst the surrounding is liquid outer core. Okay, so if we depict that in a little bit of a drawing here quickly. Okay, I'm gonna do my best to do this. Let's maybe draw just a big unscaled circle of some sort. Okay. Okay, so what I've got here, we got the crust of the Earth here. Oh, just write that properly. There we go. Got the crust. All right. This is up to 30 kilometers thick. So if you get 30 kilometers down whilst digging or drilling or whatever, that's just through the crust. Okay. Then we've got the inner layer. So I'm going to draw just another circle here. Okay, or attempt to draw a circle. Okay, here we've got something called mantle. Now, mantle is thick liquid. Okay, thick liquid, and then we've got, of course, another center circle. Okay, but over here, just the one just above, just before this one, we've got the liquid outer core. Okay, and then in the middle we obviously got, I have to decrease my brush size for this, we've got the solid inner core, which I'm going to use, which I'm going to abbreviate to IC. So solid inner core in the middle. Okay, and we have a liquid outer core over here, and we've got the mantle, which is thick liquid. Okay, now another piece of information is that the core of the Earth is roughly about 3,480 kilometers in distance. All right, and then over here, this little width here obviously is not scaled, but the mantle, okay, which is the thick liquid there, that is about 2,878 kilometers. Okay, quite far. Okay, and then from about this point all the way through to about this point, that's roughly about 12,746 kilometers. All right, now this is just obviously a depiction, all right, of what's happening, right, what's happening here. Okay, let me explain the depiction though quickly. Is that the third layer? So we got the solid inner core and the liquid outer core, but the third layer there would be the thick liquid, which is called the mantle. All right. The rocks in the mantle, they are not solid because they are too hot. Right? They're too hot, so it's not solid rock. It's molten. All right. So it's like a toothpaste in texture, but it's too hot. Don't touch it. All right. You'll burn your fingers off. All right. And there's a name that is given to this hot liquid. All right. There's a name that's given to it. I'm not sure if we can all guess what name it is, but it is called magma. Right? That's what gets released from volcanoes, molten rock. All right? The mantle is cooler and thicker on its outside edge, but warmer and thinner near the outer core. Okay, so of course, it does cool down when it reaches the outside surface of the Earth, but obviously it takes its time, but it does wonderful things when it does cool down, except that when it's actually erupting, at the moment that it has erupted and it flows, it's extremely it melts everything in its path. Okay, now the outer layer, or the outermost layer, most out layer of the Earth is called the crust. All right, it's cooler as well as it is also solid. And like I said, as it states here, it's about 30 kilometers thick. All right, but although it's a bit thicker underneath the continents than it is under the ocean. All right, so on land, the crust is a bit thicker than the crust on the ocean. Right, on the ocean floor, the crust is a little thinner. All right, so a lot of the, believe it or not, there's a lot of structure and stuff underneath the Earth, because it's probably a little bit easier to install than on the Earth for some reason. Not really so. I'm not going to get too much into that, as I don't think I'm qualified to talk about that. All right, now to talk more specifically about the lithosphere, first of all, as a reminder, it is the rocky outer layers of Earth. All right, so rocky outer layers of Earth. Now the name comes from the Greek word lith, all right, which means rocks. All right, now it's made up of three parts. All right, solid outer part, all right, of the mantle, which we know has got like very hot liquid. Okay, 2 is the cool crust. Okay, and 3, the soil, right, on the surface. All right, the soil on the surface, which is made from small pieces that have broken off the crust. Right, so that's the three parts of the lithosphere. Okay, we're obviously going to discuss them and carry on and move past through them, but basically the soil and crust of the outer mantle is basically the lithosphere itself. Okay, coming from the Greek word lith, which means rock, or rocks should I say. Okay, cool. Now all rocks of the crust, they are made up of minerals. Or not, let me not say a couple, because 2 is a couple. Let me mention one type of rock that we know we get is granite. All right, now granites have granite rock has more than one, like I think it has like several types of minerals in it. Okay, but like minerals are combination of elements and compounds, all right, that are the building block of the crustal rocks. Let's take that down. There's a definition. I just took a moment to write it down. All right, so as we know, the minerals, which are the combinations of elements and compounds, they are the building block of the rocks, all right, that make up the rock. Same way we learned earlier on in the year that a cell is basically the building block of all living things. Okay, so again, I used the example earlier. If we have a look at a piece of granite rock, okay, and Google what piece of granite rock looks like. Okay, it's all over Google. Okay, now a piece of granite rock, I'll just mention a few of these things. You'll be able to see some black specks. All right, so the black specks, of course, in the rock. Let me see if I'm spelling the specks right. There we go, specks. All right, they are crystals. All right, crystals of I think we pronounce this mica or mica. Okay, I think some people pronounce it differently. All right, and then we get the white parts. Also white specks. All right, they are crystals of quartz. Okay, crystals of quartz. And the yellowish parts, these all make up a piece of granite rock. Yellowish parts, okay, they are crystals, sorry, of what is known as feldspar. Feldspar. All right, cool. What we'll do, Grade 9, is we'll can things there for this evening. In the next unit, when we look at rocks or at minerals and mining, we'll obviously look and find out about ways that these minerals that are found in rocks can be harvested, all right, from the Earth's crust. All right, minerals such as gold and platinum and copper, all right, which is valuable minerals that are found in our countries of Africa. We'll look at ways and how they can be harvested and extracted from rocks that carry them. All right. Thank you so much for joining me in this tutorial on the Earth as a system, as well as touching on the lithosphere. And obviously the lithosphere, we're going to unpack more about rock formations and types of rocks, etc. before we end off. All right, and please don't forget to like and comment on the video, as well as subscribe to our channel, Good Better Best online videos, and we'll catch you in the next ones.